Hello students, this is Professor Flavia Letao and today we shall see what is electromagnetic compatibility engineering. In the modern world, since we humans are completely surrounded by electromagnetic radiations, it is not enough to know how to design PCBs and use the CAD softwares, but it is equally important to address the need of suppressing these radiations and avoiding interference. Therefore, talking about electromagnetic compatibility, the circuit designed should not be a source of interference as well as a victim of interference. Electromagnetic compatibility is therefore the ability of a circuit to function properly in an electromagnetic environment. That is, it should not be emitting radiations and at the same time be susceptible to outside radiations. Experience has shown that when EMC is considered right from the beginning of the design phase, 90% or more of the potential problems are eliminated before initial testing phase itself. So these all concepts of EMI EMC will be covered in our Unit 1. Now, to make the designs immune to radio and high frequency interference, in the second unit we will be looking at cabling and shielding. Grounding is again another important concept which provides less signal interference and makes the circuit electromagnetically compatible, where the signals are not lost but returned to the source. So again another concept covered in Unit 2. Grounding is the primary method of reducing noise pickup. A good grounding and bonding design can solve considerable percentage of noise problems. So Unit 3 deals with the different types of noise and how best to reduce them using the different grounding techniques. And finally in Unit 4, we touch upon yet another important concept known as electrostatic discharge or ESD. Now, what is ESD? We are all familiar with the moments when there is a discharge of static electricity, like a crackling sweater, hair sticking out when rubbed against a balloon, a small electric shock from a door handle, and so on. This phenomena is known as ESD or electrostatic discharge, which is a sudden flow of electricity between two electrically charged objects caused by contact. Now, how is this electrostatic charge generated? It occurs in very common everyday situations, like when walking on a carpet in plastic soled shoes. When this happens, mainly negative electrical charges are picked up and distributed across the entire surface of the object and body. If contact is then made with another conductive body or with ground, this charge suddenly flows off, which is what we say as ESD or electrostatic discharge. Now, even though this voltage would pose no danger to people, it could be very dangerous to some sensitive electronic devices. These devices are called as electrostatic discharge sensitive devices or ESDS and are identified by this symbol. And as miniaturization is gathering space, such devices are becoming more and more sensitive to ESD. These sensitive ICs, especially the CMOS types and so on, are not able to withstand the high ESD voltage involved. And therefore, safe handling of these devices in electrostatic discharge protected areas, that is EPAs, is of prime importance. Within these EPAs, all necessary precautionary measures are taken to ensure that work can be carried out with electrostatic sensitive devices without the risk of damaging them. All this and lots more will be made known to you in Unit 4. So welcome to Electromagnetic Compatibility Engineering. Thank you.